This is video 10, and now we're going to get into more of the quantum mechanics. A lot of the early stuff was from metaphysics throughout the ages, going back 5,000 years, 2,000 years, and we started to get into the science where Planck in 1900 discovered that we viewed the world discretely, and one of the last things I mentioned at the end of the last video was that George Berkeley believed that to be is to be perceived. Now, he said this about 300 years ago, and this really bears out in quantum mechanics, and I'll get into that. Photons travel in incremental units to their ultimate destination and not in a continuous ray, contrary to what one might preconceive. This discreteness is found in many features and characteristics of subatomic particles. I believe that as man that has evolved to quantify our world so that we can understand it and ultimately try to control it. To a great extent, we have been successful, evidenced by the scientific revolution. Yet, in an absolute sense, we are coming up infinitely short of our greatest potential by doing this. It will ultimately be man's pursuit of the infinite which will take him to the greatest heights, not his pursuit of the limitedness. In 1805, Thomas Young used the double slit experiment to prove that photons can travel simultaneously through more than one potential existence before ultimately being collapsed into its actual existence. This phenomenon, known as being in a state of superposition, developed the theory that photons have a wave-particle duality. This means that photons travel as an infinite set of waves of potential until observed, at which time they travel as a particle in their ultimate true and real path. So the double slit experiment, if you were emitting photon and you had a wall here with two slits in it, photons travel as potential through each slit in an unreal state, a potential state, and once they are perceived, one of these become real and discrete and quantized. This is an actual proven scientific fact and was the foundation of quantum mechanics. Thomas Young started this 1805, around 1927, and whereas it really came all together, and a lot of the science of today and the advancement in our society and computers and so forth is based on these provable principles. So I'll keep reading. This wave-particle duality and superposition further led to the notion of a many-worlds theory. The question arises when considering the infinite amount of unrealized potential photons. It seems possible that the photons are traveling in alternative universes while unperceived. Yet, after the collapse of the wave function, one has to wonder what happens to all the other potential photons. Where did they go? Did they ever have what could be called a real existence? Is this again a relationship between something and nothing? What does it mean for a photon to be traveling in a wave-like path of potential? In the double slit experiment, a particle does not have to choose between two slits prior to its ultimate destination by traveling as a wave potential. The potential non-existent photons collide after passing through both slits, forming a wave pattern prior to coming to be as one actual photon when observed, and the wave function is collapsed. The choice of which photon will come to be is random. So the photons are traveling here as potential. I have two here because there's two slits, but really they're traveling in an infinite amount of potential states. If they were left to be, they would collide in a state of potential if this was not here to observe, and a wave function would form at the end of this wall. This wall being an actual observation that quantizes the photon. So the question is, we perceive, here is our perceived reality, and what happens to all these other potential forms of matter that never come to be? Erwin Schrödinger came up with the argument he called Schrödinger's cat, where he argued that since photons are matter, that it could mean that all matter has a wave-particle duality to it as well. He believed that a cat could exist in a state of superposition and be both dead and alive at the same time prior to being observed. It has been proven scientifically that the fundamental units of nature have these characteristics of superposition and dual reality. Therefore, it must mean that being itself must also have this feature of existence. Absolute being must exist in an infinite number of parallel worlds, the same as the most fundamental units of our being do. We therefore must be here, there, and other places in states of unfulfilled potential all at the same time, but don't realize it for some reason. Our minds are limited. So again, we perceive and we view this one reality, and it's kind of interesting that all this other potential is out there, and we have no conception of it at all, other than currently through science and quantum mechanics. Werner Heisenberg's uncertainty principle further identified the strangeness of reality when he proved that you could not know the exact location and the momentum of a particle at the same time. The more you know about one characteristic, the less you know about the other. This phenomenon is not due to our lack of scientific capability, but an actual property of existence. Therefore, again, it shows the elusiveness of reality at its most fundamental core. This is further proof that the most fundamental units of our being are there and not there at the same time. Even the location itself is a misnomer if we assume that it was entirely still, because everything is perpetual motion, as Heraclius claimed. So what this is, again, this is a scientific fact that everybody accepts. And here is a location of a particle, and here is a direction of a particle, a momentum. The more, if we have perfect knowledge of the location of a particle, we have no knowledge of which direction it will go next. If we have knowledge of its momentum, its direction, we have no knowledge of its current location. And this is a paradox. Not a paradox, it's just an amazing thing of how elusive reality is, that we cannot know both the location of a particle and which direction it is moving at the same time. And I think with that, we'll end that and move on.